Hello and welcome to a short video about some work I'm doing in Mexico City on the development of chlorinators for rainwater harvesting systems. My name is John Chowler and hello from Mexico, where I'm working with Isla Urbana and Engineers Without Borders. And I should also note that I've received funds from the Institute of Chemical Engineers Water Special Interest Group to support this work. Today I'll give you a brief overview of my project, including the context behind the work here and some of the challenges that Mexico City currently face with water. Then I'll go over rainwater harvesting processes and how they can address these challenges and the work that Isla Urbana do. And then finally I'll discuss a little bit about the chlorination processes that I've been developing for these rainwater harvesting systems. So, first up, a bit of context. As you may or may not know, water is a scarce and precious resource, with only 0.025% of the water on this planet available as fresh drinking water. Now, Mexico City, capital of Mexico, with a population of nearly 25 million people, currently faces a serious water crisis, with many people lacking decent and secure access to clean drinking water. The people of Mexico City are faced with a water infrastructure that is aging, overworked and inefficient, which leads to wastewater contamination with potable water, child mortality from waterborne diseases and significant land subsidence. Rainwater harvesting, however, can address this problem. Given that in Mexico City there is a significant amount of precipitation during their rainy season, with a rainwater harvesting system, a family can benefit from a sustainable and clean source of water for the majority of the year. Now, I'm working with Isla Urbana, a social enterprise whose aim is to provide a future with access to clean water by implementing rainwater harvesting systems in low-income communities across Mexico. So, this is how a typical Isla Urbana rainwater harvesting system works. Here, there are 6 essential steps for harvesting rainwater. It's a relatively straightforward system, which can be adapted for the various types of households within the city. When it rains, rain falls on the roof and travels down attached gutters and tubes. The first step is the filtration of leaves and debris using a leaf filter of stainless steel mesh. The second step is the first flush. This captures the most contaminated water from the roof, allowing cleaner water to pass through to the cistern. Next up, a turbulence reductor is installed in the cistern so sediments in the cistern are not disturbed when the water enters. The fourth step is the chlorinator, which contains calcium hypochlorite tablets that automatically dissolve in the cistern, thus disinfecting the water. This is the component that I'm most interested in. The fifth step is the pichancha, a floating outlet which ensures that clean water is collected by the outlet pump and avoids the collection of sediments from the cistern. The final step is the filter train, which contains 2 filters. The first, a 50 micron sediment filter, followed by an activated carbon filter which removes organics and finer contaminants from the water. Following this, the water can be used in the household for gardening, cleaning, showering, toilets, bathing, and with additional treatment can be used for drinking water too. Recently, water quality studies of the rainwater harvesting systems have been carried out and have highlighted some key concerns. In some systems, fecal coliforms and salmonella have been detected, which makes the water unsuitable for drinking, but also unsuitable for bathing and washing and other applications. The main reason behind the presence of coliforms is a failure to adequately add chlorine into the system. You see, the chlorinator needs to be manually topped up with calcium hypochlorite tablets, which in some cases can lead to underdosing of chlorine, but in other cases can lead to overdosing of chlorine too, which makes the water unsuitable for its uses. The chlorinator is also placed inside the cistern, which means that users may sometimes forget to top up chlorine into the system because they can't see the chlorinator. Lastly, calcium hypochlorite tablets are hard to find and buy in stores, which again presents another challenge for the user to regularly and adequately top up chlorine into the system. Therefore, it's clear that we need to find a new type of chlorinator to disinfect our rainwater harvesting systems. And this chlorinator needs to do three things. One, it needs to dose at the correct rate to disinfect our system, but not add too much chlorine either. Secondly, it needs to be easy to access, so the user can easily see and top up the chlorine when needed. And finally, it needs to use liquid chlorine that's easier to find and buy in stores. And this is exactly the aim of the work I'm doing here, is to design a new type of chlorinator that doses correctly, is easy to access, and uses liquid chlorine for use in Isla Urbana rainwater harvesting systems. So, my project over the 6 months looks something like this. I need to review current chlorinator technologies that are used for small-scale, low-income systems. From these I can start to develop concepts for new chlorinators that will be compatible with our rainwater harvesting systems. From the best concepts I can then build prototypes and check their feasibility and functionality. After this, I can choose the best prototypes and begin to test them in the lab or in field as well to test that they dose chlorine at the correct level. Hopefully after all of this and after my 6 months here, I'll have a new chlorinator that we can implement into rainwater harvesting systems. So I'll just go over a bit of the work that I've done so far here after 2 months in Mexico. I've conducted a review of chlorinators that are used for small-scale systems, which include gravity-fed designs, water-powered devices, and also diffusion-based chlorinators. I won't discuss these in detail now, but I've popped a couple of links up if you want to do a bit of reading. I then refined the choice of chlorinators based on certain design criteria, such as their cost, their ease of manufacture, the type of flow regime that they use, whether they use liquid chlorine or not, and whether they can dose chlorine at acceptable levels. This has allowed me to develop some concepts for chlorinators that we can use in rainwater harvesting systems here. For example, gravity-fed designs that may use a wick or a spring-loaded switch, or for example water-powered designs that can use, for example, a venturi to deliver liquid chlorine into the water pipe. And finally, diffusion-based chlorinators that, although using solid chlorine tablets, offer a very simple and easy to access solution for the users. Now, I'm currently constructing and prototyping some of these designs to test their suitability with Isla Urbana rainwater harvesting systems. So that wraps up my progress and my project here in Mexico City at the moment. Just thought it'd be useful to tell you a couple of reflections about my work here so far. 1. Get used to working outside your comfort zone, especially with different cultures and a different language. 2. Things that you may think are straightforward to do are not always so simple. 3. Being able to apply my skills in engineering that I've learnt over the years in developing countries and really make a difference to people's lives is an incredible experience for me. So I'd like to thank you all for watching and listening about my project and my work here in Mexico today. So if you have any questions, feel free to email me here at my email address, john.charlotte@gmail.com. And also make sure to look up the work that Isla Urbana and Engineers Without Borders UK do. Some really great stuff. And then finally, I'd like to thank the support from the Institute of Chemical Engineers Water Special Interest Group, and also from all donations on my Just Giving page for this project. All your funds are much appreciated and it really makes a big difference. Thanks very much for watching. Goodbye.